Thank you for joining me. I'd like to share some information that I presented at a recent meeting in Obregon, Mexico. For this presentation, we'd like to talk about passive acoustic monitoring as a tool to assess feed response and growth of shrimp in ponds and research systems. Now, this is collaborative research done in my laboratory. I have a lot of people who help me out, particularly Silvio and his wife, Roberta, who are out of Brazil. And he's really responsible for being able to do the recordings and transform those recordings into things that are usable. So the first thing I want to talk about is why listen? You know, we hear dogs bark, we hear birds singing, humans use noise to communicate. Many noises can be interpreted if we just listen and then try and take the time to interpret them. So I think the first question is, well, how do we listen to shrimp? It's no different than, listening in air. We're just doing it in the water. Now, there's a little bit different terms used. Passive acoustic monitoring is the term used when we're listening in the water. And it's a non-invasive approach using a hydrophone or simply a waterproof microphone. These hydrophones are placed in the water to detect sounds, and then the data can be recorded, listened to directly, or software processed in real time. And I think we're all familiar with, whales singing, but a lot of our crustaceans also make noises. If we look at the Pacific white shrimp, this is a recorded, synchronized, and you can see right here, as the animal chews, his mandibles come together and produce this click that you see and hopefully can hear if I'm not talking. So as the animal chews, he makes this little click, and that click can be recorded. In the laboratory, we'll record it and use some software known as Raven, which is actually developed by Cornell Labs for bird calls. But using this recordings and analytical software, you can look at the pulses of clicks, the acoustic characteristics of those clicks, or the energy. And so we see right here on the right-hand side some examples of clicks. But we can actually analyze the durability, the energy, the intensity, the frequency of these clicks. And so you can look at where the energy is produced. And it's across a range of frequencies. And one of the nice things about that is if you have something that is interfering, you can screen out lower frequencies or a frequency area and try and remove that interference and still maintain part of this click and be able to pick it up. So we found it a very interesting way to look at feeding activity and analyze what's going on. So one of the things that you do have to realize is there are potential sound interferences. So at least in the laboratory, we do try and make things a little bit quieter than normal. But as I said, these can be screened out. So you can easily take out different wavelengths, and this click goes across a number of wavelengths. But you can see the example here where they initiated feeding, and they're going through, and then here's one of those clicks that's being brought down here, so you can actually see what's going on in terms of energy intensity and the noise that's being produced. So we can visualize the effects of feeding and what's going on. And this has a lot of application. The acoustics can be used, things that we're looking at is, well, what processes in the feed affect the click, how fast they click, how fast or how loud that click is. So there's different processing technologies, what I'll call shear of the kibble, because we may have extruded or pelleted feeds, the thickness of that kibble, the length of the kibble, how palatable that feed is, all are going to affect the noise coming from that feed. And then we have animal influences. So different species give a different noise profile. The size is going to a certain extent, affect the profile, both the intensity and the wavelength. We see that stocking density, water temperatures, stress factors such as oxygen, the presence, maybe presence of feeds. All these things could affect the acoustic signals. And then we have the application of those signals in terms of the commercial industry, where we're seeing this in automatic feeders. And actually, we're looking at this because of the automatic feeding industry developed this technology. And so we're trying to look at ways to help improve that technology and understand what's going on. But, you know, the feeding area, which means the density of feed that's being laid out, the size of the feed, the spin rate, you know, realize that the area that's fed is based on how fast that motor is spinning and able to throw something, but also the size and the weight of that product that's being thrown out there. So there's lots of things. And then there's factors that are affecting this also in terms of environmental quality, so water quality, soil quality, numbers of animals. All these things are interesting things that we can kind of look at around this optic of acoustics and feed management. So what I want to do is kind of go through this talk and provide you some information on kind of what we know in the laboratory, what we've learned, and then also give you a glimpse of how this is applied commercially towards the end of the presentation. So if we look at acoustic research in the laboratory, we can apply this to all the systems that we have, different size tanks, aquariums. We've used a number of different ways of looking at this. Now, if you want to try and get the cleanest recordings, you do need to turn off aeration. We found that having a soundproof top helps, and water flow may have to be taken down. But you do want to try and minimize the noise that's in the area when you're trying to do these recordings. But we can do these recordings in a fully aerated and, you know, water exchange system. So it's very nice because you can have a growth trial going on and then you can do these recordings without being invasive to the animals, or minimal invasiveness. So I think it's a very interesting tool for the laboratory as well as the field. So some of the things that we've looked at, one of the initial studies, we simply got different extruded and pelleted diets. And what we wanted to know is if there's any tests that would correlate good to the characteristics. And what we found that the break point, or using a texture analyzer to break that feed, gave very good indication of how much noise would be produced. And there was a good correlation there. Now, we don't have a huge amount of data on that, but I think that's probably going to be the best correlation. Density of the feed may also serve as a proxy, but I think that the break point is probably a better indicator of how efficient the noise will be produced. Now, just as an example, this is a 30-minute recording. Silvio has an 8-hour recording that I made him do, which is going to take a lot of time to analyze. But we're getting some really interesting data because you can do this continuous recording and look at what's happening with the animals. Now, this is just simply a pelleted and extruded diet, and so they're going to have different breakpoints. And as you can see, you get differences in terms of the noise. One of the things I do want to point out in this recording, and so it goes out to 30 minutes, this is a measure of the energy. But as you can see, it comes down relatively quickly, and the vast majority of the energy that's produced in feeding seems to be in the first 5 to 15 minutes. Even though we can go out as long as I said, our longest recording is 8 hours. But typically, recordings are done about for 30 minutes. We've looked at the length of the kibble, and to do this, we actually did some acoustics recording in soundproof chambers because we wanted to see if there was any difference in terms of the actual characteristics. So we did a lot of individual animals, group animals, as well as some isolated animals, acoustically isolated. Anyways, we looked at the same diameter pellets, but they were of different lengths. And what we found is that the frequency, the characteristics were identical. So length does not have an effect, and that's what you would think would happen on the characteristics of that signal. But we did find that feeding behavior was a little different. Now, think about this as if, if you had a small candy bar, a medium-sized candy bar, a large candy bar. The small candy bar, you might actually be able to eat in one bite, or maybe a couple bites. But the longer it is, the more bites you're going to have to take. And that's exactly what we saw with the shrimp. If you look at the number of clicks, for example, as we increased the length by approximately twice, we got about twice the number of clicks, and they increased the length by about twice as much, and you got twice as many clicks as that. So the number of clicks is correlated to the length of that pellet. But what we thought was very interesting is that in the smaller pellets, they consumed them much quicker and came down to satiation as opposed to the larger pellets. And so there may be some advantages to having shorter or longer pellets. So again, looking at that at different length, we did break that down into smaller groups, so 5-minute intervals. But as you can see, you have a decrease in activity. And so we see most of the activity, now that we're looking at these recorders, probably in the first 5 to 15 minutes, and then they come down to satiation in terms of that initial feeding response. So again, simply looking at this, this is at 15 minutes. And you can see that the slopes of these curves are much different in terms of correlations. You have a very good correlation of food consumption with energy, first thing to point out, but also that there's different slopes. And so you had a much steeper slope with the small animals because they consumed it much quicker, okay? Or the small pellets. Apologize. Now, again, we've looked at feeding behavior, and we've done this a number of different ways. So this is an example where we looked at two different sizes of animals, a 4.5 and a 13-gram animal. These are top coating. So we took a commercially produced open formula that we've done at our facility, an all plant, about 8% poultry meal and 8% fish meal, and then a 12% fish meal diet. And so we wanted to simply top coat with a couple of attractants. So we had fish hydrolysate and also krill oil. So we did some quick top coating with those. You can see them up at the top, and then looked at the acoustics. And again, this is energy log transform over time. And so you can see the energy starts off very high, and then it's going down. And I'll point out that we do have a range of ways we've presented this data. Sometimes it's as the energy captured at each point. Sometimes it as the cumulative energy. So these graphs will maybe go from left to right going down, or right to left going up, depending on how we looked at things. But you can see that there's very different slopes to these lines. And our all plant diet is down here in this light yellow, and it has a fairly low level of energy to begin with and a very flat slope. And if we look at consumption, so again, looking at consumption over 30 minutes, you can see that we did get differences in terms of consumption. Now, one of the issues that we have with measuring consumption is it's a relatively small quantity of food that you're actually calculating on. And there's a fairly high variability in it. And so these traditional levels of giving that animal food and then recalculating, there's a lot of different issues with that. It's a good tool, but again, it does have some issues. And again, I'll point out that we did look at 30 and 15 minutes, but you can see most of the activity looks like it is happening in that first 15 minutes. Now here's our larger shrimp. Again, the same response essentially to the diets. We do see differences in consumption that is correlated to differences in energy consumption, of the clicking. Now, so here's another example where we made the diets. So these are laboratory produced diets, but we looked at krill hydrolysate, krill meal, and krill oil, all at either no inclusion in a plant-based diet or 1, 2, and 4% level of inclusion. And that is on a dry weight basis for our fish hydrolysate. So that's a very high level of fish hydrolysate. So we made the diets. So this is incorporated in the diet as opposed to being top coated on the diet. And again, so this is cumulative energy. So it's going up as opposed to going down. But you can see that, the different slopes again correlate to, intake of food consumption. So we did the recordings at the same time we did food consumption, and so we can correlate those two back together. And you can see the fish hydrolysis, krill meal, krill oil all had additions, improvements. Now, our most recent work is where we're looking again at feeding behavior with commercially produced feeds. So this was an all-plant diet that we ran in our pond production system. I'll show you some results of that later on. And then we added 2% krill, 2% squid meal, and 4% fish hydrolysates. Realize fish hydrolysates is approximately 50% moisture. Consequently, we added twice as much so that we could be in the same ballpark on a dry weight basis. And then in this case, I'm showing a 12% fish meal diet that was actually made the year before. And what's interesting is this, a year later, this diet outperformed our all-plant diet. I'll show you that data. But please realize that that diet has a different matrix of ingredients. And so we don't know if it's because of the matrix of ingredients or if it's, something that happened during processing that made it, or storage that made it much more palatable. But it's about a year old. So again, we can go into our aquariums. Silvio has a pretty nice recording system, and he can do, I believe, well, here we show we're doing 4 tanks, 1, 2, 3, 4, 5. Yeah, I think we can do 6 tanks at a time, and you get a recording. And what I'm showing you on the top is an example of recording with those clicks, but then we've gone in and grabbed this smaller component of time and pulled it out and expanded it so you can see what those individual clicks look like. And this is a very nice tool because you can go in and actually sum up the energy or sum up the number of clicks after you've cleaned up the recordings a little bit. And then we have some really nice tools for looking at consumption. So this is an example of, again, looking at feeding behavior. On the right-hand side is our different diets that showed the color codes. And what we did is we took naive shrimp. So they were being reared on a commercial feed formulation. And then, stocked them in the systems, got them in the systems. And then we simply converted them to this. So this is the first time that these animals have seen the feed on the left. We're calling that naive shrimp. And then we conditioned them for about 4 days. And then we did another recording. So we did these first initial recordings on naive. They hadn't seen the feeds, and then later on, after they've been conditioned for 4 days. And this is the recordings in 15 minutes. But you can see, even if you go out to longer regression times, 15 minutes is where most of that activity is occurring. And that's the reason that we're a lot of times just using the first 15 minutes, although we do 30-minute recordings. And so you can see that the responses are very similar from the naive and the non-naive shrimp species. And we do see differences in slope of those, and that our all-plant diet is not being consumed as quickly as these others. And so this is, I think, the main advantage. Now, when we're doing these recordings, of course, we come in and we can recapture the feed that's being left over. So we can then look at the actual intake. So again, here's our 4 diets that we're primarily concerned with that were made at the same time. And you can see that our all-plant is not being consumed as quickly as the other 3 with attractants. And it doesn't matter if you're non-naive or naive in terms of the response. And so putting that data all on one slide to make really a big mess. Now, I brought this fish meal 12 back in, but as I said, to me, it's not a very good comparison because this is a well over a year-old diet, which at the time in previous recordings, it actually gave similar results to the all plant. So for some reason, this matrix is different. So anyways, if you look at that, the all plant diet, we then get improvements. And for whatever reason, this fish meal 12, which as I said, is a completely different year of making that diet, we got the best response. But you can see this number of clicks corresponds very well to the response of the animals in terms of feed consumption. And if you do a regression on the data, both naive and non-naive, looking at feed consumption and the number of clicks. You can do it at 15 minutes or 30 minutes, and you both get very good regression. Our thing is that right now what we're seeing is that about 75% of the activity is occurring in that first 15 minutes. So to us, that's where kind of the action's happening. That's where we're kind of concentrating on things. So in the laboratory, we've learned a lot about feeding behavior because you can quantify over time using a non-invasive procedure. We can identify characteristics of the feed that are influencing the clicking, which is then correlated to intake. And so this is allowing us to look at feed effectors, things that are going to affect food consumption, whether or not it's because of attractability, palatability, but bottom line is the animals are grabbing that food and doing better, eating it faster, which to me makes sense for leaching and other things. Now, to me, we can apply this into our daily management of our farms. I want to remind you that feed management, like all processes, continually be improved. I'm a big fan of continual improvement, lean manufacturing, or whatever terminology we'd like to use, but we need to continuously look at our processes, continually challenge whether or not we're doing things right or whether or not we're doing things wrong. We look to other industries, particularly the fish industry. Automation minimizes the loss and increases feed input. So it makes sense that we in the shrimp industry need to automate. And if you look at the feed management practices that have been used to automate feed management in fish, which is a lot easier to manage because you can see the response. These can all be applied, maybe a little different technology, but they can all be applied to our shrimp. So remember, fish systems, it's very easy to have on-demand feeding because even in murky water, we can see the response if we use a floating feed. And these were actually feed that were already been fed. So they're, this is the way I like to keep fish. Keep them hungry. We don't feed them as much as they want because then they get lazy. So I'm a big proponent of restricting feed management, but it's very easy to see those guys are consuming the feed and wanting it. Well, can't really see shrimp in systems. There's very few systems where we can see the shrimp. So what's the next best thing? Well, we can use the acoustics to manage our shrimp. And that's what all these new feeders are doing. So to give you some examples, I'll walk you through just very quickly some of the things that we've done in the past, as well as some of the things that we're doing, planning to do. Now, we spent a lot of time looking at feed management in my facility in my laboratory. So what I want to show you is we spent maybe 4 or 5 years where we went from hand feeding and we optimized all our hand feeding. We got to a very good feed management for hand feeding. Then we moved to, we actually got the AQ1 in-house. And so we wanted to move to standard operating procedures for automatic feeders while validating the AQ1. And so we spent 3 or 4 years moving towards an improvement in automatic feed management. And so we've already done all that work. This was the next to last experiment that we did. So we had improved our feed management pretty much with automatic feeders as far as I thought we could do it. And what we wanted to do is simply look at day feeding, night feeding, and 24-hour feeding, okay? But we also ran our acoustic. So this was, as I said, our management practices using automatic feeders, and they're feeding every 20 minutes. So we had combined a bunch of different feed managements, essentially, that we'd done in the past. So this is a cumulative of what we had as standard feeding rations, curves, which were combined. And then at this particular point, we looked at daytime feeding, nighttime feeding, and then 24-hour feeding. So we gave the same amount of feed and the same number of feedings. It was just whether or not we fed during the day, during night, or both. And then we had the AQ1, who is, again, managing based on acoustic management. So again, just to show you the production that was done, we got very good production, and this was what we consider our typical and good production. And as you can see, even though we had been playing for the last 5 years, improving our automatic feeding, we still did not match our AQ1 system. And so at this point in time, we said, okay, we have worked on the automatic feeders for some time. We now need to convert all to acoustic management because it has a lot of advantages. So we've got data on, performance, and then we simply went to all acoustics, and that is what our facility has been for the last couple of years. And I will let you guys understand, moving to these higher engineered systems, we'll just say, you do have to learn the electronics. You do have issues with, maintaining things. You have to learn how to run these systems. It's not just throw it into your system and walk away. There's lots of little things that happen. For example, we have rodents that like eating the wires. We have fire ants that like getting into the electronics. We have electrical strikes, hurricanes, winds. So you have to learn how to manage and adapt these systems to your environment. It's not simply just sticking it out there and magically they work. So last year, or the year before last, we wanted to look at whether or not these acoustic systems would feed differently for different types of protein bases. So we did an all plant diet, 8% poultry, 8% fish meal, and 12% fish meal to look at the effects in acoustic systems. And we allowed the system to manage itself, and we got absolutely no differences across the board. This is very clean data, 4 replicate ponds for all the data. Well, a couple ponds have 3, but good data, good production, good feed conversion, survivals, and so we didn't see any major differences across these protein sources, but we felt that the all plant diet, of course, could still be improved. And so our production from last year, again, working in the same systems, Glot Petite, we're running 16 0.1 hectare ponds. We stocked at 30 shrimp per meter squared. And again, we ran about a 90-day production cycle, which is what we've been doing with the automatic feeders. We do a 2-week nursery. We do that for biosecurity reasons. I want to be able to quantify the animals that go into the ponds and make sure that any mortality due to shipping has already occurred and the animals are in good shape. So again, we took our plant-based diet, which we've got a number of years of performance with. We simply added krill at 2%, squid at 2%, and a fish hydrolysate at 2%. Now, both the krill and the fish hydrolysate, we've looked at those in the laboratory, and we found that they had good responses. And of course, squid is one of the more popular attractants that are used in aquaculture for shrimp feeds. So again, we wanted to look at that. So the first 16 days, when we stock our ponds, we are feeding them by hand. We then transition to a timer feeding from day about 17 to 43. So after the first 40-ish days, we can then transition to our acoustics. We do have an upper limit set at 160 kilograms per hectare per day. And we did hit that on occasion, but we didn't hit it every day. Okay, so we were not restricted in terms of the amount of feed that was being fed. We do have the AQ1 system, which is monitoring both our DO and turning on our aeration. But we do hand measure in the morning and the afternoon. Number one, we need to get pHs. We need to check on equipment, and I want to make sure that our readings are correct. And we get a similar reading between the AQ1 reading and our hand measurements. They're not hugely different, but they are a little bit different. Now, this year we had lots of issues. Number one, last year, we had a huge amount of rain. We actually, halfway through the season, did a small water exchange where we brought in seawater because our salinities had dropped down to about 6 parts per thousand. Then towards the end of production, we do another exchange, which we, again, because of our low salinity, we used full strength sea or high salinity water. It's about 20 parts to do that exchange. And then we got hit with a hurricane. Now our low salinities, where a lot of times we were down at about 6 parts or lower. We had blue-green algae problems in several of our ponds. And, you know, very difficult to treat blue-green when you're dealing with shrimp. It's difficult with fish, which are not have less sensitivity to copper and other treatments. But we did lose ponds because of the blue-greens. And then the hurricane hit just as we were trying to harvest. So not only did we have a hurricane come through during harvest, but we also had our fish pump break during harvest, and we had to go get our backup fish pump. So basically we started harvesting, had everything, all our ponds down. Then we ran away for the hurricane, and then we came back just as the hurricane was pushing through during the bad weather, so we could be there to get the ponds taken care of as soon as the weather cleared. But we did lose a number of ponds in those last couple of days. We're not sure if it's due to DO or why we lost those ponds, but we did. Just to give you a visual in terms of the sizes of the shrimp, and those shrimp don't look any different. These are actual shrimp from the different treatments. And I know this is a busy slide. I'll show you some bits of it, but this is all of our production. And you know, one of the caveats is that, for example, the all plant, we have 4 reps. For the krill meal, we have 3 reps. For the squid meal, we only have 1 rep. And for the fish hydrolysate, we only have 2 reps that made it all the way to harvest clean. We do have our grams, our sampling, weekly sampling data. That all makes it, you know, up to the last sampling. So that data is clean. But this is not what I consider the cleanest data, okay? Just to show you graphically in terms of yields, and again, there's no statistical difference in weights or yields, but we did have higher yields in the krill, the squid, and the fish hydrolysate. And you can see that we did put in higher levels of feed into those. You can see our growth rates here on the right-hand side. This is not the best growth or the best feed conversions that we've had. Personally, I think our genetics are not where they need to be because we did not see good growth across numerous systems. So I think this is more a genetics than a water quality. Now, to look at the average inputs of feed for those different ponds or different treatments, here's our data. And as you can see, about day 40, we transition from our timer feeders on and realize, you know, there are times when it's raining too hard and we can't get out there to feed. There are timers, or the standardization goes out of whack also. So these are, you know, like that blip up high is because the standardization was not correct. We recorrected that because it was feeding more feed than it was supposed to. But bottom line is, you know, we get those things solved. And you can see, you know, very obviously that the fish hydrolysate, they pretty much fed more all the time for the fish hydrolysate. And then the all plant, which is here in red, had pretty much the lower feeding. Remember, we did intakes and acoustics with, this example is a non-naive in the laboratory, and we saw similar things. The data here from production does not mean that they clearly consumed more, because those ponds also have higher biomasses. And so it may simply be that the acoustics is responding to biomass. Irrespective, we got a generally more feed input, and we got generally more biomass out of those systems. Now, we also run in parallel to our ponds, our outdoor tank systems. So these are green water systems. We stock them at a similar density. These are fed at a fixed ration, and we're using pond water from our production ponds to run through this system. So we simulate natural productivity. We call it a green water system, but it's a very good validation for what we do in the ponds, although it's not acoustically fed. And we do have a standard ration that we feed, and because we were looking at attractants, we did add a standard ration plus 30% for a couple of the treatments. I'll point that out here in a minute. So again, we looked at the same diets, our krill meal addition, our squid meal addition, and our fish hydrolysate addition. And if you look at the results after 9 weeks, we got very, reasonable growth. Again, this is not great growth for us. So again, it points to genetics not being the best. We only got about 1.1 grams per week, where our best is around 2. But we can see that, these 2 treatments we chose are all plant because that's our basal. And then before we ran any of these tests, our assumption was the krill meal would do the best because that's what we saw the best performance in the laboratory. So we chose that as our other treatment, that we increased the feed by 30%. So we intentionally overfed these animals. And so if you grab, for example, the krill, normal and overfed, you can see the weights aren't any different and the biomass is really not any different. So we weren't underfeeding to the point that we were restricting feed. And the feed conversion went down, right? And the protein retention, which is the last right here, apparent net protein retention went down. So we weren't restricting the feed. So we did not, under these conditions, see any major differences in terms of final weights. We did see some difference in terms of biomass. And that biomass, because we had lower survivals, and that lower survival did occur in both groups. So it may be that we're missing a little bit of something nutritionally in this particular variation of our plant-based feed formulation. Now remember, from year to year, these are going to change. But what we can conclude is that we did see a slightly higher biomass, or significantly higher biomass, for the krill, the squid, and the fish hydrolysate. And this corresponds back to our data in our ponds. And so I think we're validating that, even though the pond data is not as clean as we would like to. Now, from a historic perspective, we've seen that changing feed management from 2 feedings per day to timer feeding is an improvement. It's a huge improvement, actually. We cut 30 days off our production, getting to the same size animals simply by going from 2 feedings to automated feedings. And then moving to acoustic self-regulating feedings is a further improvement. And you can see this in the industry in Ecuador. Ecuador, over the last 5 years, has gone to having a few feeders that they were evaluating, to the major farms now have probably 90 to 95% of their ponds converted to either automatic feeders or acoustic feeders, because having those multiple feedings really benefits the shrimp in terms of performance and the quality of nutrition going into those shrimp. So the take-home message: acoustics have multiple applications in ponds and research systems. Acoustics in the lab is a fantastic tool. We can do a lot of things with it because it's non-invasive and we can see what's happening over time. In terms of acoustic feeders, I'm a very big fan of them. It improves our feed management. It increases feed inputs and growth. It reduces feed conversions and number of days to markets. Now realize, when you go to an acoustic feeder, technologically, there's a lot of things that have to be right. And because you're using technology to do things, your people have to accept it. And you have to figure out how to make them work in your environment, because different environments have different challenges. In our case, we have 90-mile-an-hour winds that literally drove rain into our waterproof boxes. And we have to deal with electrical issues because of that. We have fire ants that get into our electrical. We have to figure that out so that we can make sure these systems work. So none of these systems are foolproof. You have to be willing to invest the time to make sure they're working properly, but they're a great tool. Now that we have these tools, now that the industry is embracing it, we need to understand the factors affecting the signals. What's the effect of different diets? Are there preferences? Can we affect consumption, attractability? And those are kind of things that we're working on right now in the laboratory. And with that, I'd like to recognize, of course, that I have a big team of very bright students behind me. I have some very good research scientists that we work cooperatively with, for example, out of Brazil and other places. And that they're the people who make this happen. I just get to get up here and try and share that work with y'all. If you've got any questions, I'd be happy to answer them. I thank you very much for your time and your patience. Hope you all have a great day.